Hi everyone. Okay, so in this example we have two rigid bars, AB and BC. They're fixed to pin supports on the ground, which means they can't move back or forth, but they can rotate if they wanted to. We've got some forces pulling on them, and we're going to assume that these bars are weightless. Okay, they're just going to assume that they're weightless. Now we want to figure out what the forces in these bars are. We need to figure it out. So let's see what we can do. Now, there's many methods we can use, but I'm going to use my preferred method, which is to break everything into components. Now, this kind of looks crazy because you didn't see it be built up. So I want to show you how we got this free body diagram, okay? We're going to go backwards. We're going to see how we got that free body diagram. Now, the first thing I do is I cut around a point that seems like it connects everything, which would be point B. I want to get the forces inside this bar, so I need to figure out what the force AB is and the force BC. So after I've cut, I'll bring it over here, and I start adding in, I draw arrows for anything I cut. So I draw one over here, draw one over here. And I add any arrows for things I know. Well, I'd have 1,800 pounds going to the right, and 2,000 pounds going down. Okay, so 2,000, 1,800. I name things, so I'll have a force BA, because it starts at B and goes to A. I have a force BC, starts at B and goes to C. That looks pretty good. Now let's add some angles. Well, I'll make one to the horizontal direction. And so this one will be 45 degrees. You're wondering, well, how in the world did you get that? Well, here's my line. Mascazaro kind of thing here means that this is a similar triangle. So 45 degrees. Similarly, on this side, this is 60 degrees, kind of Mascazaro thing going on, similar triangles. So 60 degrees. Okay. Now from this point, I need to break it up into components. Now I'll show you how to do that for each individual one on the next page. So this one already shows you what the components are, but I like to pull them apart so you can see it. So we're going to take each of these individual forces and figure it out. You'll also notice that in this particular case, they drew force BC going towards the point instead of away from it. The reason for that is because if you draw the arrow going the wrong direction, you'll get a negative number for the value of this force BC. And so they, just being infinitely knowledgeable, already know what direction to go, and so they just drew that direction. So if you get a negative number, don't worry about it. That's just saying that you drew your arrow in the wrong direction, okay? You drew your arrow in the wrong direction. And you can fix that if you want to. Just be very careful that you actually flip your arrow around in your picture if you do that. So first off, let's break up force AB. How do we do that? Well, first I'm going to take it over here, and I'm going to turn it into a triangle. Okay? I turn it into a triangle, so it's going to have a horizontal component, and it's also going to have a vertical component. You do not have to draw these in color. I will not judge you if you don't. And then you add in any angles. Well, I already told you that this angle is 45 degrees. And now let's name things. Well, this side is force AB. And, well, this is the side that's going to be adjacent. This is opposite. And now I just use my basic triangle steps. So I'll call it force ABX. Force ABX. Well, that's going to be the adjacent side. And how am I going to get that? Well, it's adjacent over hypotenuse. Okay, so adjacent over hypotenuse is equal to, well, that's going to be cosine of the angle. So that's cosine of 45 degrees. So I multiply both sides by the hypotenuse. And I get that adjacent is equal to the hypotenuse times cosine of 45. Okay. And so therefore, this is the adjacent will equal force AB cosine of 45. And then I do the exact similar thing for force ABY, which is the vertical component. You can also call it force AB vertical. You can do what you wish. What you call it doesn't really matter too much. The vertical component will be the opposite, and we already know the hypotenuse. So we'll make sure we put in terms of that. So opposite over hypotenuse is what? Well, let's write it out and see. So opposite over hypotenuse, yep, is going to be equal to, what is it equal to? Oh, it's sine of 45. Sine of 45 degrees. The degree sign outside, that's weird. Multiply both sides by the hypotenuse, it cancels over here. What I'm left with is that opposite is equal to hypotenuse sine of 45 degrees. So force ABY is equal to force AB sine of 45 degrees. Now we have to be very careful though, because force ABX, you notice it's going in the negative x direction, so I'll make that negative. Force ABY also going down, that's negative. Make sure you keep your negative signs there, that is important. Now I'm not going to do the same thing for force BC. I'll let you just do that on your own time. But once you've broken it all up, now we add up all the x components. So this force is in the x direction. We have a horizontal component from force BC and force AB. We get one equation. So all the forces in the x direction, they have to equal 0 at the end. I do the same thing with force in the vertical direction. So all the forces in the vertical direction have to add up to 0 at the end. I've got two equations, two unknowns I can solve. So what I'll probably do is I will simplify. I simplify my first equation right here to get everything in terms of force AB. And then I'm going to plug it into my second equation. So wherever I have force AB, I'm going to plug that this into that spot. So once I've done that, I have it all down here. This is all in terms of force BC I can solve. And I get that force BC is 2,782 pounds and force AB is 579 pounds. If you had drawn your arrow like this, you would have gotten that this is a negative 2,782 pounds, as long as you were careful to keep everything else constant. So be very, very careful with that. But that's it. This is how you solve these problems. You will have to do some algebra. If you don't like algebra, your calculator can actually do a whole lot of algebra for you. If you learn how to use the matrix abilities of your calculator, you can do so much of it. I'm not going to show you how to do that though, but if you really want to learn, try it out. And if you figure out how to do it and do it well, I might have you make a little demo video for future students. If you do, a little bit extra credit. So thank you for listening to this example. I hope it helped you, and I'll see you all next time. Bye-bye.